Hi students, small request Nana, without subscribing my channel you are watching my videos. Please subscribe students, please support me, then I can do more videos. Okay, please Nana, please subscribe students. Thank you students. In today's session I am going to discuss about the VBT Nana, valence bond theory. It is a topic from 12th class, lesson name coordination compounds. So this is the complex COF6 3 minus. Here I'm giving the trick box Nana. See here, trick box. Calculate first. We have to find the oxidation number of metal atom Nana. Calculate oxidation number of the metal atom. And second one, the given ligand is weak field ligand or strong field ligand. You have to identify students. If it is weak field ligand, fluoride or chloride, okay, 3D electrons do not pair up. And next, if it is strong field ligand, 3D electrons can pair up students here. Okay, weak field ligand, it cannot pair the 3D electrons. The strong field ligand, it can pair up the 3D electrons. Okay, now see students here, first I am going to discuss the, here this is the central metal atom, this is the ligand. Here F given, fluoride, F minus is which ligand? Weak field ligand. F minus, weak field ligand. So it cannot pair up the 3D electrons students. What is 3D electrons? That I will discuss here. Okay, now see students, it is a central metal atom, it is the ligand. Ligand is ready to donate the lone pair of electrons to the central metal atom, because here central metal atom metals are we know that always ready to lose electrons because of loss of electrons. They become electron deficient, so that's they are ready to accept the electron pair from the ligands. Are you understanding? So first I'm going to trick box. First one, calculate oxidation number of the central metal atom. I'm going to calculate the oxidation number. Cobalt, I'm going to calculate oxidation number Nana. I'm taking as X. Cobalt I'm going to calculate. So I'm taking as X. 6 into 6 fluorine. Fluorine is the fluorine oxidation number -1 equal to charge how much given? -3 given. So X minus 6 is equal to -3. X is equal to how much students? -3 plus 6. X is equal to +3. So oxidation number of cobalt is how much Nana? Cobalt oxidation number is +3 students. Okay. Now here I am taking cobalt oxidation number is +3. Okay, 3 electrons lost. So CO +3. Now what is atomic number students? Actually cobalt atomic number is cobalt atomic number 27, correct? Scandium, titanium, iridium, chromium, manganese, iron, cobalt 27. Electronic configuration argon 4s2 3d7, correct? 3d7. This is the electronic configuration. Argon 4s2 till here 20 electrons over. This is 27 electrons completed. Okay. Now CO +3 is nothing but 3 electrons lost. Where it lost? From fourth shell 2 electrons. From 3d 1 electron lost students. From the valence shell first it is losing electrons from the valence shell. Next remaining electrons from the inner shell students. Penultimate shell 3d. Okay. Now what is the electronic configuration of CO +3? CO +3. Electronic configuration what students? Argon. From 4s 2 electrons completely lost. 3d 7 kada, 1 electron lost. Here 2, here 1. Total 3 electrons lost. So that's why I'm taking as 3d6 4s 0. Correct? 3d6. Here 1 electron lost. Here total 2 electrons lost. 3d6 4s 0. Right. Now orbital structures I'm writing. CO +3. Okay. CO +3. Orbital structure 3d6. So in 3D, total 5 orbitals will be there students. 1, 2, 3, 4, 5. Total 5 orbitals and 1 4s is there. 3D 4s. 3D how many electrons there students? 6 electrons. 1, 2, 3, 4, 5 and one more electron here. 4s is completely vacant students. No electrons. Okay. Now you have to hit here completed. Now second trick observe Nana, ligand. Given ligand is weak or strong ligand. Here fluoride is a weak field ligand, so that's it cannot pair up the 3d electrons students. 3d electrons do not pair up here in the case of weak field ligand F minus. So here F minus is their ligand, it is a weak field ligand, it cannot pair up the 3d electrons. So that's why 3d orbital structure as it is will be there, these electrons as it is will be there. Okay, now you have to observe how many ligands are there. 6 ligands are there, so that's why 6 ligands are ready to donate the 6 6 pairs of electrons to the central metal atom. So that's why in central metal atom total 6 vacant orbitals required, because to accept the 6 pairs of electrons from the 6 fluorine ligands, it requires 6 vacant orbitals. Are you clear? Because each orbital capacity 2 electrons. So that's a 6 fluorides are donating the 6 pairs of electrons to the cobalt. So that's why in cobalt total 6 vacant orbitals required. Here only one orbital is there, vacant orbital in cobalt. Still how many orbitals required? 5 required, because 6 fluoride ions are there. So I am taking 4p is completely vacant. From the fourth shell, valence shell, 4s, 4p, 4d, 4f will be there, because in the fourth shell 4 subshells will be there. I am taking how many required? That many orbitals only I am taking, students. 4s already one vacant orbital there. 4p I am taking here. 4p, how many boxes? 3 boxes. This is 4p. 1, 2, 3, 4 only there. But how many required? 6 required. 1, 2, 3, 4. Still 2 required. That's why I am going to take from 4D also. Here place not there, students. Here I am taking 4D. Total how many boxes? 5 boxes in 4D. Now which orbitals? How many orbitals required, students? 6 vacant orbitals required now. 1, 2, 3, 4, 5, 6. That means only till here. From here to till here required. Are you understanding? These 3 not required, students. Okay, only 6, because 6 fluorides are there. That's a 6 vacant orbitals required. Now this 6 vacant orbitals I am writing in one place. These 3 boxes writing separately. Okay, like that we have to write. Now see, students, 6 vacant orbitals, right? Now these 6 vacant orbitals, students, undergoing hybridization. That means one s orbital, total 3 p orbitals, 2 d orbitals. How many s? 1. P, how many boxes? 3. 3 p orbitals. D, how many boxes? 1, 2. 2 d orbitals. Are you clear? So what I told you, 1 s orbital, okay, 1 s plus p, how many? 1, 2, 3. 3 p orbitals, 2 d orbitals. Clear? 2 d orbitals. Undergoing which one, students? Hybridization. Hybridization produces, students, how many total? 1, 2, 3, 4, 5, 6. Correct? Total 6. S how many? 1. P how many? 3. sp3. D how many? 2. sp3 d2 hybrid orbitals are formed. Are you clear? Hybrid orbitals are formed. Understood, Amma? Okay, now this 6 sp3d2 hybrid orbitals I am writing in one place. See here, CO plus 3 equal to 3d as it is I am taking. Total 5 orbitals, 3d. Okay, next this 6 orbitals I am writing. These are 6 are sp3d2 hybridized orbitals. Total how many? 6. 1, 2, 3, 4, 5, 6. These are 6 sp3d2 hybrid orbitals. Clear? Hybrid orbitals. Remaining 3 are which one, students? The extra orbitals. These 3 we have to write separately. Okay, these are 4d orbitals, correct? 1, 2, 3. These 3 I wrote separately. 4d. Are you understanding? 4d. Okay. Now electrons you take CO plus 3. 1, 2, 3, 4, 5, 6. This as it is I am writing. Right. Now these 6 sp3d2 hybrid orbitals of central metal atom undergoes overlapping with the 6 fluoride ligands. Now this 6, now in cobalt how many boxes there's vacant orbital? 6 there. Now it is ready to accept the 6 pairs of electrons from the 6 fluorides. Okay, that's why these orbitals are undergoing overlapping with the 6 filled orbitals of the fluorides. Okay, so these orbitals are undergoing, these hybrid orbitals are undergoing which one, students? Undergoing overlapping. Now these orbitals are undergoing which one, students? Overlapping with the which orbitals? Filled orbitals of 6 fluorides. Are you understanding? Filled orbitals of filled orbitals of which one, students? Overlapping with the filled orbitals of 6 fluorides. Clear? Filled orbitals of 6 fluorides. So here you have to remember, this is important. Are you understanding? Overlapping. They are undergoing overlapping. Here hybridization. This word is important. Are you clear? Don't confuse. Okay, so in the same atom, orbitals are undergoing hybridization. Now these atom orbitals and fluorine atom orbitals are undergoing overlapping. Okay, in between the two different atomic orbitals are undergoing overlapping. Okay, now when they are undergoing overlapping, students, what is happening now? 6 fluorides are donating the 6 pairs of electrons to cobalt atom. Okay, now so 6 pairs of electrons donating, students. Here 6 vacant orbitals there. Now here total 6 pairs will come. Okay, now see here I am taking this orbital structure CO 3D 1 2 3 4. This is 3D. This is 6 sp3d2 hybrid orbitals are 1 2 3 4 5 6 filled with 6 pairs of electrons given by the ligand, students. So that's why we have to take here what we have to write, electrons of ligands. So this is the electrons of ligands. Okay, electrons of ligands. Now which one? This 4D no need to write, students. Directly you can leave also, no problem. Here 6 orbitals, hybrid orbitals are filled with, first you write 3D electrons 1 2 3 4 5 6, right? Now these 6 orbitals are filled with 6 pairs na, because 6 fluorides are giving the 6 pairs of electrons. So this 4D also you can write as it is, total 3 boxes 3D, 4D as it is you can write. Now see, students, till here you have to do Nana. Next Nana, conclusions. What are the conclusions? Now we have to write hybridization geometry. Conclusions. First one, hybridization. What is the hybridization, students? Hybridization, tell me. What is the hybridization? sp3d2. sp3d2 na. So right here sp3d2 hybridization. What about the geometry, students? sp3d2 hybridization there means geometry. What is the geometry? Geometry sp3d2 hybridization. This one, octahedral geometry. What is the geometry, students? Octahedral geometry. This box, trick box, you have to remember, students. sp3 means tetrahedral, dsp2 square planar, sp3d trigonal bipyramidal, sp3d2 d2 sp3 octahedral. Okay, then you can easily understand. So geometry sp3d2 means which geometry? Octahedral geometry. Clear? It is octahedral geometry. Next, what you have to write, Nana? Magnetic nature, magnetic property. Now tell me, students, magnetic property, how to tell based on the 3D electrons? Magnetic property. And tell me magnetic property. Only 3D you have to see. 3D electrons, here unpaired electrons are there. So here unpaired electron, paired means diamagnetic, unpaired means paramagnetic. So the given complex is paramagnetic in nature. Are you clear? It is paramagnetic. Are you understanding? So magnetic property over. It is inner orbital complex or outer d orbital complex. In the hybridization you see, Nana, sp3d2 came. Means after sp3d came. That means this is outer d orbital complex. If suppose d orbitals are front side there before sp3, that is inner d orbital complex. Just you have to identify by seeing this hybridization, you can write easily. So after sp3 d2 there, that is outer d orbital complex, because here fourth shell 4d, fourth is the valence shell. So valence shell d orbitals, 2 d orbitals are undergoing hybridization. So that's why valence shell orbitals are undergoing hybridization, that is outer d orbital complex. If suppose third shell d orbitals are undergoing hybridization, that is inner d orbital complex. Okay na? So here in sp3 d2, sp3 after d2 is there, that is outer d orbital complex. If it is before there, before sp3 d orbitals there, that is the inner d orbital complex. So it is outer d orbital complex. Clear students? Outer d orbital complex. Clear Nana? I hope you like this video students. If you like this video, please like, share, comment and subscribe my channel Nana. Thank you students. Thank you very much.